Sorry. There we go. Okay, our last video cut us off, but let's pick up where example 3, where we're going to pick up where we left off. Now remember, I need to find my least common denominator after everything is factored. Looking at these, 1 is really just over 1. Don't forget we can pull a 3 out of our second equation. And our last one can't be factored. So looking at all of this, I'm going to say my least common denominator is a 3 and a 2x plus 1. So we multiply each top by 3 times 2x plus 1. So 1 times 3 times 2x plus 1. All over 1. We have 1 times 3 times 2x plus 1. All over 3 times 2x plus 1 plus x minus 5 times 3 times 2x plus 1. All over 2x plus 1. Remember, our second step is to cross off and simplify. So my 1's cancel out, my 3's cancel out, and my 2x plus 1 cancels out. And on the last one, just the 2x plus 1. So I have 3 times 2x plus 1 is equal to 1 plus 3 times x minus 5. We can go about and simplify. So I have 6x plus 3 is equal to 1 plus 3x minus 15. So 6x plus 3 is equal to 3x minus 14 if I combine like terms. Move my 3x to the other side. Move my 3 to the other side. End up with 3x equals negative 17. Divide by 3. X equals negative 17 over 3. And it's fine to just leave that as a fraction. Don't forget, double check. What are my no solutions? Two x plus 1 equals 0. So I'm not allowed to have negative 1 for a solution. Or sorry, negative 1/2. Negative 1/2, not the same thing, so I'm okay. Let's look at example number 4. This one looks like we're going to have to do potentially a lot of factoring. First one, we have p plus 3. Not factorable. P minus 6, all set. P squared plus 3p. Well, I can pull a p out of both of those. Over here on the top, I can pull out a 5. And then again, over here on the bottom, I have p that I can pull out. So let's look at my no solutions first. Set each part from the bottom to 0. So p plus 3 equals 0. Oops. P cannot equal negative 3. And p cannot equal 0 according to the bottom of my fraction. And my least common denominator, one of everything, I have p and p plus 3. So p plus 3 all times 1 over p plus 3 equals p minus 6 times p times p plus 3 all over p times p plus 3 minus 5 p minus 3 times p plus 3 all over p times p plus 3. Cross out, simplify. P plus 3 cancels out with p plus 3. P plus 3 and p plus 3, and the p's cancel out. P's cancel out, p plus 3 cancels out. Rewrite. 1 times p is p. I have a p minus 6 minus 5 p minus 3. So distribute my negative 5. Bring everything else down. Combine like terms. Bring my p to the other side. Divide everything by 5. Is 9 over 5 one of my two things that I wrote down as no solutions? No, so I know 9 over 5 works. Let's do one more example from the tries. Let's do example number 1. So again, no solutions. Things that are not allowed to be solutions. N plus 3 cannot equal 0. So n cannot be negative 3. And then 4n plus 2 cannot equal 0. So 4n cannot equal negative 2. N cannot equal negative 1/2. Those are my two solutions that will not be allowed. So now let's get into our problem. N plus 3 can't be factored. I can pull a 2 out of 4n plus 2 though, which means I can also pull a 2 out of this 4n plus 2. My least common denominator looks like it's going to be 2 times 2n plus 1 times n plus 3. So I multiply each numerator by this. So 2n plus 1, n plus 3, all over n plus 3, minus 2, 2n plus 1, n plus 3, all over 4n. Let's leave that in its factored form. 2 times 2n plus 1 is equal to n minus 1 times 2 times n plus 3, and we also need a 2n plus 1, running out of space. All right, we simplify. N plus 3 cancels out with n plus 3. 2 cancels with 2. 2n plus 1 cancels. 2 cancels. 2n plus 1 cancels. Rewrite. So I have 2 times 2n plus 1 minus n plus 3 equals n minus 1 times n plus 3. Phew, we've got our work cut out for us on this one. Distribute 4n plus 2 minus n. Distribute my negative. minus 3. FOIL n squared plus 3n minus 1n minus 3. Combine like terms. 3n minus 1 is equal to an n squared plus 2n minus 3. Let's move these over to the other side. So this is equal to 0. Okay, now don't forget, when we have a trinomial equal to 0, we still have to factor to solve. So I need to factor. They both get an n. Negative 2 times a positive 1 gives me negative 2, but adds to my negative 1. Set each part equal to 0. Alright, so I have answers of 2 and negative 1. Double check, are those am I not able to be equal to solutions? Nope. So I know these both will work for an answer. N can be equal to 2 and n can be equal to a negative 1. Alright, I'm going to cut that off for our video notes though, because I don't want them to be too long for you. If you would like to see these other this other one example, I'll solve it out and post it in the answer key on Google Classroom. Have a great night.